Hey guys, Koda Karnas here. Welcome back to the workbench. And today I thought I'd take you through my design for my K40 laser cutter, which you can see here. Picked up last year. This is the jury rig setup I had running last year, and I'm just now in the process of automating it and cleaning it up a bit. So what you're looking at here is green tank contains distilled water, blue tank contains ice water, and I'll explain what that is shortly. But I thought I'd take you through some of the modifications I've made to it so far. So this is it here with its head up, hood up. As you can see, the orange pane of Perspex in the middle there, that's this is how you look through. What I've added is around the outside, I've added some LEDs so I can turn on extra lighting so I can get a really clear view of what's going on in here. I've put an extractor fan here which sucks air into this box from around the electronics, which is stored in this bit, and two fans here which suck air from the outside in, blow it in across the workbench here and down into this vent, which is, you can just see in the background there, a bit of a fan where it gets sucked out the back. Um, Also had to, and I'll bring out a closer view, on the initial unit I got when I first got it, this vent here actually stuck out about a good inch further, like 2-3 centimeters further. So the head here would hit against it when it was trying to traverse across the top. So whip that off, slice a nice chunk off, put it back in. So the head's now free to run backwards and forwards. Um, Another change I've made is I've changed the front panel from having just a push button switch like this into a key switch. Just I prefer the key switch rather than a switch, which was quite hard to see if it's running. If you look at the electronics bay, I have replaced the controller board that it comes with. So I'm now running a Cohesion board, and that's a safety key switch there. And what you can see is if you follow these wires down, you find that actually there's one end and the other one's somewhere off the bottom of the screen. Um, I've actually cut the safety cord here, and one of my things is I'm going to put a board up in here which has a automatic controlled safety cutoff. So if my controller software decides that regardless of what the rest of the system says, the laser isn't enabled, it will just disable the laser. And I'm also going to be able to control lights and fans separately. You can see the power supply in for those. Now the cooling system, which is what I'm here to talk about, is, let's see if I switch photos to the back. Bit of a mess, sorry, it was my work in progress. Distilled water here comes up, in here, around the tube, then back out, around this thing, and then back into the tank. And then the cold water from here comes up. And why do I have this complication? I'll get onto the piece of paper and I'll draw it out and talk to you about it. So normal setup, if you get the system out of the box, you have a tub of water and you have laser tube. Laser tube goes in, water comes in, hot water comes out. And what you do is you have a little pump which pumps water into there and then returns to here. Now, that works absolutely well and good. A little pump which I had, which it came supplied with, was struggling to provide the amount of lift I wanted and get the water flow. A lot of the systems I read online says you need to maintain around about a litre per minute running through this and keep the temperature around about 25 degrees. Please do your research. I am not an expert in this. I've had some training in lasers many, many, many years ago when I was at university, but yeah, do your own research, figure it out for yourself. But the best I can see is, 1 litre per minute at 25 degrees C maximum. So that's really the max you want to run. Problem is, I live in Australia. And as I sit here currently, it's 29 degrees or 32 degrees outside. So if you have a tub of water just sitting in ambient, that'll quite often just sit at 20 degrees C. Just under my workbench will hit 20 degrees C in the middle of summer, which is getting a bit close to my liking for this. So what I did in that strange curl black thing, so this thing here is what's called a, this thing here, I'll indicate it there, this one here, is what's called a wart chiller. And I'll see if I can find a better picture of it. Yeah, it's one of these. So what you have is you have a braided outside pipe wrapped around a copper pipe on the inside. So what we have, as you can see here, there's a pipe coming out and a pipe coming in at both ends. There's two pipes, two connections at both ends. So what's that for is, if you draw it out, what you end up with is you have a pipe in and a pipe at the top. The pipe in, I'm going to draw it straight because I don't want to draw curves like this. And then you end up with an outer sheath like this, all the way up. Not the best drawing, but you get the point. So what you do for this sort of thing is you pump hot water in the top. So we'll cut this, divert the hot water into here, run through, and then dump that back in. So we don't have that connection there. Now, what we want to do then is counterflow. So cold water in here. So you get warm water coming out. Counterflow your coolant. Now this is basically a heat exchanger. And if you've ever, read up on nuclear reactors and stuff like that, or places, this is how they cool it. So you have your coolant loop here, which keeps the reactor cool. And then you have a system here, which keeps the coolant cool. And what I do is I have a big drum over here, which in the picture, if you go back and look at the start of the video, was you got me thinking now, what color drum was that? That was the blue drum, I think it was. Yeah, the blue drum. So if you look at my original pictures, this is a green, this is a blue tanks. So this has a pump in here, pumping cold water out, and then the warm water flows back in to the tank. Now, this here, because it never actually touches the laser tube, I just run pure tap water. Plus ice, and that's the key thing. This over here is distilled. So it's distilled water here, tap water here. If I want to get this really, really cold, I just go down to the garage, just buy a whole bunch of ice, and chuck little ice cubes in here. And rapidly, this water will get down to 4 degrees C quite quickly. So then when I'm flowing it back through here, water comes in, gets warmed, and then gets chilled running through here, and then gets dumped back out into the tank. And when I was playing around with this setup before Christmas last year, I was getting easily a 10 degrees C delta from here to here. So if it was coming at 25, it was coming out here at 15. So my idea is when the system's running, if this tank of water is a bit hot, I just turn it on, don't turn on the laser, just turn the pumps on, get this system circulating, and watch the temperature of this water drop. Now, when I went out and bought the pumps, what I ended up buying was fountain pumps. So these are the things you use for your fountains and your outside, just general low volume or low pressure, high volume, not even high volume. They're just pumps your garden fountain. And the major reason I got them is because I had lift. So head lift is how much will this pump lift? And the one which is in my main system in the green, that'll lift 3 to 5 meters high. And this one will lift 1 to 2 meters high. I'm not too worried about this system. This system wanted to get the flow. Testing when I had the system, when the system's up and running, I'm getting about 1.5 to 1 3/4 liters per minute through the system, which is good. This one, because it's actually not lifting as high, It doesn't need to actually go up to the top of the laser chiller. It just needs to go around the water chiller. This is getting about 1.5 litres, even though it's a smaller pump motor. Now, one of the issues I found is these things are designed to just run constantly. You don't turn them off, you don't turn them on, you just leave them running. But I don't always want this running to chill this water. Otherwise, what will end up happening is this water will get too cold. I'll then start getting condensation on this tube, and then I can end up starting getting those shorts because this tube's running, was it 8,000 kV, 20 kV, large number of kilovolts. Yeah, really high voltage across it. You don't want water beading on the outside of the tube. So you don't want the water too cold. So if I flick back to the photo, that button there, right, and I'll switch to close-up of the blue tank. Right, pumps here. So that's pushing water up here, and then the water then travels up here into the water chiller. Now, if I want to turn the system off, I don't want to turn this pump off because the pumps don't like being turned on, turned off, turned on, turned off. So what I've done is I put a bypass solenoid here. So when I activate the solenoid, the water will then follow the easy path and will just cycle around the side of this tank. And that's got the nice thing of if this full of ice, if the water level's down here and the rest of it's full of ice, having a constant flow of water means you end up with keeping the water really cold. And it just keeps on circulating it colder and colder and colder until it's nice. And then when I shut this valve, the water then gets rediverted up here, around the water chiller up here, and then back out down this way, and then back into the tub. And that's all good. That seems to work fine as this is my prototype. It works quite happily, so I'm now in the process of sorting it out. And so I want to monitor the system because, I'm an electronics engineer, I'm a software engineer. I want to have some fun with this apart from laser cutting. So what I've got is, if you look at this picture here, and if we look at sorry for the massive wires, but you'll see here, I've got this white unit here and one on the blue tank in the background over there. So those are the flow sensors that I've done a tutorial on. So they measure the flow coming back from both the ice. I call this the cooling system and the ice system. So they measure the flow coming back into both. And then also you'll see here is a temperature sensor. And that there, even though you can't see it, is another temperature sensor. You can see the wire going in and down. So that's temperature sensor for the return water. And there are the plugs which aren't connected to anything at the moment. So what I'm planning on doing is I got a temperature sensor attached to this unit. So we'll just call that temperature out. And this one here, temperature sensor attached to this water, which is temperature back. So that will measure the delta of the temperature through these two. Mostly, I want to make sure that the temperature of the water going into the tube is, no higher than 20, 25 at most, because it'll get heated up along here. But I also want to see what the temperature is coming back to make sure this is working. So I have two temperature sensors, and I also have a flow sensor attached here. Now, one of the questions which was asked when I was talking to a friend about this is, why have I put the flow sensor here, not here? Because realistically, if I put a flow sensor here and the pipe pops off here, well, this will still measure tons of water flowing out, but there will be no cooling. So I've put the flow sensor as close to this end of the pump. And actually, if you look at the pictures, you'll see that the flow sensor's pipe actually terminates. Out of the flow sensor is the dump into the tank. So if the pipe breaks anywhere along this whole path, yes, so if it snaps here, basically I'll just be pouring water onto the floor. Yeah, I've lost 20 litres of cooling water, but the flow sensor will rapidly reach the zero and it'll disable the laser. So that's what I want to do on this side. And funny enough, exactly the same on this side. So flow sensor here, temperature sensor here measuring what I'm putting out, and a temperature sensor here measuring what I'm bringing back in. So that's the sensors I've got running here. And I've also got, as I mentioned before, I've got the bypass here. So I've actually got the bypass solenoid here. So the water can actually then flow that way if I want to. So I need a solenoid connection. So this side, 2 temperature and a flow. This side, 2 temperature flow and a solenoid. And the last system I've got is I have a temperature probe attached to this and a humidity probe. That sits inside the back of the case where the tube is housed. And I have a switch for the lights, the fan, and also the laser enable. So those are relays. So we'll call that RL, R, and RR, and these are the sensors. Now, my plan is, and this is why I've been doing a lot of these tutorials, because I've been playing around making sure I understand how it all works, is I'm going to have nano sitting here, nano sitting here, and nano sitting here connected to all these. And each of these 3 nanos are going back to a Raspberry Pi, which has all my control software on it. So these are just going to be using USB serial. Out there and to there. So it is that these will all be connected. And the Raspberry Pi, which I'll do another video on at some stage, will basically get all this information, feed it in, make the decision, and then it has to then tell this, enable the laser if all the flows are, if all the water's flowing, all the temperatures are happy. So it just constantly monitors the system. And yeah, that's it, guys, I think. As I said, I'm going to do a deep dive into that at some stage. I've done all the videos for all the various tutorials on how to talk about these things. So in my next series of videos, I'm actually going to make up the boards which the nanos are going to sit into, solder in all these, get all that wired up, and then hopefully in within the next couple of months, I should have my laser cutter up and running again, which would be good because it's been down for most of winter while I was rebuilding the system. So hope you found that interesting. Like and subscribe. If you have any questions, please leave them below and stay tuned for the next one. Bye.